Hello. In this video, I'll walk you through the end-to-end time series forecasting system, a production-grade solution built for data science assignment provided by the company for the testing as a data scientist or the ML engineer role. The problem, weekly retail sales data across 10 US states spanning from January 2019 to December 2023. Our goal is to forecast the next 8 weeks of the sale for every state automatically using machine learning models. Okay, here we have trained four different forecasting algorithms: Sarima, Facebook Profit, XGBoost with lag features, and LSTM deep learning model. Uh, we have engineered 42 features with zero data leakage. Uh, we automatically select the best model per state on hold out of performance, and we expose all prediction through the production REST API built with fast API. Now let's dive in. All right, here is where upper part is where we have added all our required libraries that we have needed. Our data set was then added, generated this part. Okay, let me just check this. Our data set is a weekly sales of uh, 10 US states as we discussed, from California, Texas, New York, Florida, Pennsylvania, Ohio, Georgia, Michigan, and North Carolina. Okay, it has 26,000 rows, uh, 2,600 rows, and 260 weeks per state. Notice that about 2% of the values are missing, which is common in the retail. So we group the state by California. Missing values are filled from California's own history, not from Texas or from the other state. This is a criticality so that the mean value that we are using to fill the missing state, or rather say mean median mode, can be used for filling up here. So we are using per state, not depending on the other state, so the data doesn't go mismatch. Okay, so after that, we group the state first. So California missing values are filled from California's own history. After cleaning, the data has cleared uptrend. So yearly seasonality, holiday per week from December to November to December, and notable COVID dip in 2020. That is the part, I think, is this part of the graph, that EDA part, exploratory data analysis, that we did. That what are the flows uh, part. Now we come to feature engineering part. See, in EDA, month wise, you can see this parts. All right, and then we come to feature engineering. All right, now come the feature engineering. Feature engineering, we captured the sales uh, look like 1, 2, 3, 4, 8, 26, 52 weeks ago. So okay, I have printed that right. Yeah. Then 52 weeks lag is especially powerful. It tells the models what sales were impactful. Like you can see, I have defined it at in the function two part here. As you can see, these part. Uh, Basically, the feature engineering is done to make any feature that is not required to either drop off or removed. And if existing two features do the same part, either combining them or leaving one drop off. Second is the rolling statistics that we computed for 4 weeks and 8 months. 4 weeks and 8 months, 3 months and 6 months. Rolling means standard deviation, max min. These features are critical as we use it to shift one before rolling, so we never get into the current period to predict the current period. All right. The third calendar feature, month quarter. weeks of years, clinical cyclically sine cosine encoding for the month, and encoding for means January, December's are treated close together, not far apart. Fourth is US flags are US holiday flags means use the holiday of library tag used in the federal holiday plus the near holiday flag list within 7 days. This capture the pre-Christmas sale surge. All right. Then we come to the model training part. This correlation matrix, that part, right? Model training part. First, we begin with Sarima. Now, the core system we train for our four complete different models. For one is Sarima. It stands for Seasonal Auto Regressive Integrated Moving Average of 1D, 1 and 11052, where D is determined automatically by augmented Dickey-Fuller's stationary test, and the seasonal period is 52, 1 year of weekly data. Then comes our model two, that is model profit, Facebook profit. Profit handles the trend and seasonality automatically using the decomposition model, which works better when seasonal swings grow with level of series, plus US holiday effects or custom month for year seasonality. Then we can go to XGBoost. XGBoost with lag features. XGBoost doesn't understand time series natively, so we fed it all 42 engineered features for multi-step forecasting. We use recursive strategy. Each week prediction is appended to history and make compute next week lags. This makes it genuinely looking forward. Then we can go for long short term LSTM model. Oh, our LSTM model uses sliding windows of 26 week as input. We implement it with scikit-learn MLP regressor, a deep learning neural network with 128 and 64 128 layers, 64 hidden neurons, which is functionally equivalent to a LSTM in terms of learning from the sequences when combined with window logic. It can swap from it can be swapped with PyTorch for LSTM level production. And I guess it has the output training and test wala part. All four models trained, the scores appear in real time and system automatically. Now I think we have put the model CV means per model state walkthrough. Model selection summary. Like uh, how should I explain this? Model visual summary. Here the model selection for the leaderboard. Okay, yes, this can be understood, right? California, XGBoost, Sarima, Profit means which model have far performed best for which state. For California, it has been XGBoost. For Texas, it has been, hmm, where is that? Model per state. California, LSTM, California. Okay, California with LSTM, Texas with LSTM, New York with LSTM. Uh, its map score means the evaluation metrics was used here. And completely at the end, we can see that LSTM was overall better for 7 state, XGBoost for 2, and Profit for 1. And now for visual forecasting, California best LSTM model. This is Texas, this is New York, Florida, and model comparison that we did. So this was the overall result. As previously seen, the LSTM has the most 70% of the time, 70% of the time performed best. All right, so that was mapped. XGBoost's performance. And finally, the 8-week forecasting, and rest was the API part. Fast API server. We get back the 8-week forecast confidence intervals. The model used the MAE for every model, that is mean absolute error for every model. So consumer can see exactly which model performed. Uh, Actually, I ran it today in the morning and I'm recording it in the evening. So, okay, I'll try this at a good time. If I remember, I should get this part. Huh? We can also override the model. Maybe the business wants a profit taxes, and regardless of the automatic selection, just add the model equal to profit for query parameters. If you want to just switch for the customized part, means this part should be handled by profit and this part should only be XGBoost. So we can switch that. Returns the service status. It was good. Many endpoints it calls for Ohio for the best, and similarly for the other states. And this is how I guess we saved the model, downloaded in the, what should I say, this part to my files, and running this all means it take more than what it took me previously. Model training part took me an hour, and so that will take one more part if I need to submit that. I think I have not downloaded that. Yeah, no, it's here. It is saved. The models have been saved here. I'll refresh and check as well. Okay, to summarize this, I would like to end the clean data pipeline with the proper missing values, handling with proper state, 42 engineered features, lag, rolling, statistics, cyclic calendar features, holiday proximity with zero data leakage. 4 production ready forecasting model as said, Sarima, Profit, XGBoost, LSTM. Automatic model selection was given per state to hold out test mean absolute error. REST API with 8 endpoints of fully Swagger documents, JSON responses, confidence interval, live interactive dashboard for visualization and forecasting comparison. Uh, Thank you for watching. The full notebook, source code, API, and this documentation are included in the submission package that will be submitted now. Thank you.